could hear it. All right, so here we go. We're gonna pick up 5-4. I can't use the scratch board, so we're just gonna go with real board. A to the x is e to the x ln a, so pi to the x power, how do I rewrite that? E to something, right? E to the x natural log of pi. So I could rewrite that since pi is a number greater than 0. So we had that. That was one of the results we had. We also have other theorems that we had in from algebra. So remember in algebra, let's look at some of these things. We have x to the n power times x to the m power. What is that in algebra? What's that equal? We'll start going around the room, Hannah. Good, x to the n plus m. So same base, add exponents, right? So if I have e to the a power times e to the b power, what do you think that equals? That's going to be e to the a plus b power, right? So x can be any real number. E is a real number. What's e about?
2.79.
More specific. No. So 2.7818, 28, 18. Never ends, never repeats. So e is an irrational number. Okay, it's about 2.71828. So anyway, but we have some of these rules here. By the way, we could prove this as well, but they use natural logs in that proof. Anyway, what do we have? Here's another thing. What if I have x to the m divided by x to the n? What would that equal? Who's up? Drew?
So it'd be x m minus n.
X to the m minus n power, right? So if I have e to the a divided by e to the b, what's that going to be? E to the what?
ea minus b.
E to the a minus b power, right? So these are pretty obvious things. We also have one more algebra thing. If I have x to the m, then to the n power, what's that, Elijah? Rewrite this as what?
X m plus n.
X to the m times n. X. Should that have me do this? We say a to the m to the n is a to the mn. That's the amen rule. Because if you don't know, you better start praying. All right. Anyway, so what do you think e to the a quantity to the b is?
I'll do it.
Go ahead.
E to the a times b.
E to the ab power. Okay. If you forget these rules in algebra, just give yourself a quick little check. So how do we give a quick little check in algebra? Give yourself a real life example. So x squared times x cubed. What's that equal? Well, you can go definition, right? So how do I use a definition x squared? What's that mean, Garrett?
X to the fifth times exponents.
Prove it. Yeah, it's equivalent to x to the fifth, right? But why? Like, prove it, because I mean the question is that x to the fifth or x to the sixth? Do you add the exponents or do you multiply them, right? So if you forget, how do you prove it? What's x squared mean?
X times x.
X times x. What's x cubed mean?
X times x times x.
X times x times x. How many you got? It's x to the fifth power. So exponent is repeated multiplication, right? Just like multiplication is repeated addition and exponent is repeated multiplication. You remember this stuff? We did this in Cup 1. You didn't all remember it then either. What if I got, let me just do x cubed quantity squared. Well, that's going to be x to the sixth, but prove it. Who's up? Haas? What's x cubed mean?
X times x times x.
So it's x times x times x quantity squared. So what's that mean? It's x times x times x times itself twice, right? How many you got? 6 of them. Okay. Same thing here. What if I got, let's just do x to the 5th divided by x squared. Let's do this rule. What's that going to equal? Well, according to the theorem, it's x cubed, but let's prove it.
5 x's
So it's x times x times x times x times x
and 2.
over x times x, and if x is not equal to 0, so that's in this theorem, x can't equal 0, otherwise you're dividing by 0, right? What happens? We get 2 of them to cancel out. Top and bottom, they cancel to 1s, right? So we're left with x cubed, right? Is that it? Those are kind of the major ones that we had, I think. So anyway, so if you forget those rules, just give yourself a quick, simple example. But obviously, we don't want to have to write it out by definition like this. If I have x to the 500th divided by x to the 200th, that would be way too much writing. Okay, so we have those theorems with exponential function as well. And then we started getting into the derivative and antiderivative. So the derivative with respect to x of e to the x power is what? Anybody remember? What's the derivative of e to the x? Cameron? E to the x, perfect. So didn't I cover that last time?
No.
No, but you should have been reading ahead, right? So anyway, page 462. So the derivative of e to the x is e to the x. So what does that mean? And in reality, what's e to the x look like? Can you draw it for me in the air? I'll stand you, Cameron. So this is something we had. Draw it in the air. It explodes, right? So sometimes we call this the natural exponential function. Okay? But what is the derivative measure? Hannah, back to you.
Rate of change.
Instantaneous rate of change, which is graphically the what?
Oh,
Slope of the tangent line. So the slope of the tangent line at any point on the y equals e to the x or f of x equals e to the x curve is going to be given by e to the x. So the slope of the tangent line out at e is going to be e. Isn't that nice? Slope of the tangent line of e squared is e squared. So that's pretty cool, right? This is really a neat thing. So put the cool factor emoji on that note. So anyway, so let's look at another example. What if I have the, what if I want the derivative with respect to x of e to the x squared power? What if I want something like that, derivative of that? So that's not e to the x, that's e to the x squared. Well, we need an alternate version of this theorem. So another version of this theorem is if I have a function up there, so the book uses d sub x, but you can use d dx. But if I have e to the u power, they just use e to the u. So what does that mean? That's a function in terms of x. So use u as u of x, really. You could put e to the g of x if you wanted. But anyway, we're going to act like it's okay. So it's e to the u. Because the derivative of e to the x is e to the x, so the derivative of e to the u. But it's not okay, that was a function up there, so times the derivative of u with respect to x. So this is how they write it. Derivative of u with respect to x. That's not how they write it. Derivative of u with respect to x. They write it like this. So I'm going to write it like the derivative of e to a function, let's just say e to the g of x. So that's a little more obvious to me that that's a function in terms of x up there. So we're going to act like it's okay. It's e to the g of x power. Act like it's okay. And then times the derivative of the exponent. So times g prime at x. So to me, this is a much easier way to write that theorem. So it's kind of like, it is basically a version of the chain rule. But anyway, instead of the derivative times the derivative of what's inside, it's times the derivative of what's upstairs. It's not that hard, so it's pretty similar to what we did. So coming back to this one, where are we at? Is that one? Maybe. Well, you should have let it go because you're going to be the one to do the second one. So we're going to do a cheer. Anyway, I love Mondays.
No, you don't. Nobody does. Tim does. No, you don't.
E to the x squared, not when I didn't bring my stuff, but we're going to figure this out anyway. What's the derivative of this one? Where are we at? Who's up? Drew?
2x.
No?
Or, should we rewrite it first, or?
No. Derivative e to the, it's e to a function, right?
Mhm.
So you act like it's okay. You didn't do that.
Isn't it just 2x e x to the second?
Fine, but I'm not gonna write it that way.
Okay.
I'm gonna act like it's okay. So it's e to the x squared times the derivative of the exponent. So you just weren't done yet? Is that what you're saying?
Yeah. So you don't put it out for anyone?
Well, you can, yeah. I mean, normally I'm not gonna, like, if you rewrite this, or if you say, what's the math etiquette way to write that? It'd be 2x e to the x squared is an easier way visually to see that. Okay, so usually put the constants in front. And it's pretty obvious that x is not in the exponent here, where if you have it times x there, it's hard to see. So I didn't know you weren't done yet. Okay, all good? You want to try one on your own? Okay. Example, let's do the derivative with respect to x of e to the 3x squared plus 2x minus 4 power. What you got? Who's up? Eli.
The derivative is 6x plus 2. Oh, but e to 3x squared plus 2x plus 4.
So you act like it's okay. So it's e to the 3x squared plus 2x minus 4 times the derivative of the exponent, which is 6x plus 2, right? So then if you want, you can pull that, write that in front. The 6x plus 2, if you want to pull a 2 out, you can, and have the quantity x plus 3. If you're looking for zeros or x-intercepts, right? Set where the height is equals 0, whatever. Anyway, we're not, oh no, that's not true. This doesn't have an x-intercept. Does it?
No.
I don't know, maybe it does. I don't think so. I'd have to think about it. I don't know. Anyway, we're not graphing that. This is the slope of the tangent line. So if you're trying to figure out where this equals 0, we could factor that part. All right. Anyway, all good with that? So the derivative of e to the x is e to the x. Derivative of e to a function is e to the function times the derivative of the function. Pretty simple deal. So what about the antiderivative? So let's just look at an antiderivative. The antiderivative of e to the x power with respect to x, what do you think that is? Who's up? Okay. The derivative of what is e to the x? Isn't that how we always answer this? We answer the antiderivative with what's the derivative? The derivative of what, I mean? The derivative of this side is going to equal e to the x.
Yup.
So what would this be?
E to the x.
No.
X to the e. Times plus c.
E to the x plus c. Yes.
You really
Okay.
got that plus C.
You have a plus c problem, which typically ends up in a C plus problem for your final grade. But you know, unless you fix it, so let's just fix that deal. All right. So antiderivative of e to the x. All right. Well, that's fine. What if what I don't like about this book, if you're looking on page 463, they use a u there, but they're not saying that u is a function of x. So I really don't like that. They do on the derivative, they don't on this. But let's look at an example, shall we? What if I want the antiderivative of x e to the x squared dx? So this would be a fun one.
All right.
Garrett.
Yeah.
Can you do this one in your head, Garrett?
No,
Obviously not, so what are we gonna do? You mean act like it's okay? I don't like that e to the x squared. I don't like that x squared. I just want e to, like e to the u.
bring that, put that front.
Can't put it out front. It's not a natural log. What did we do back in section 4.2?
Let u equal.
Yep. So we're gonna let u equal x squared, then what's du equal?
Two x.
2x what? It's really du dx, derivative of u with respect to x, right, is 2x. So then we move the dx over here, right? Remember that?
Yeah.
And then what else do I got here? I've got x dx right here. So there's my x dx. So what's that equal? Divide both sides by 2. All right, so you can't forget what we did before. So du over 2 plugs in for x dx. So this is equivalent to 1/2 and then a du here. The x is gone, right? The dx is gone, and it becomes 1/2 du, right? Everybody good with that? Do you see how I sub that in? And then instead of e to the x squared, what is it? It's e to the what? E to the u du. So what's the antiderivative of e to the u du? Cos. So it's 1/2 because that's out front. Multiplication. What's the antiderivative of e to the u? Du.
U to the U plus C.
It is. So it's e to the u plus c. And then what do I do here now?
Plug x squared back in for you.
That's BS on your paper. It's back substitute, right? So it's 1/2 e to the, what was it? X squared plus c. So that's the antiderivative. So the antiderivative of x e to the x squared dx is 1/2 e to the x squared plus c. I don't believe it. So how do I check it, Carly?
Take the derivative of it.
Take the derivative. So if I want to check this, I can take the derivative of this answer with respect to x, right? So that's a d dx. So take the derivative of that, what do we get? What's the derivative of 1/2 e to the x squared plus c? I'll go up here on the check. Derivative with respect to x of 1/2 e to the x squared plus c. Well, plus c is out here. What was that again? Keep going. Still up, Carly. Trying to keep you from yawning. Derivative of constant times the function is the constant times the derivative of the function. What's the derivative of e to the x squared? Okay, no reason to look confused on this. We just did this one. If you don't know where to look it up. Huh? Sammy, please, can you? Yeah, act like derivative of e to the
E to the x squared equals 2 to the x.
yeah. So you act like it's okay. It's e to that thing times the derivative of that thing. So times what? 2x. So what happens to 2? Those cancel, right? What do we get? We get x. And what's the derivative of constant? No, wait a minute. I wasn't done yet. Stop it, Shay. Derivative of constant is 0, right? Am I recording this?
Yeah.
Hey, here's a replay of Shay dancing. All right. Anyway, is that what we wanted? Is that what's in here? Look at that. Check. It checks. Okay. Pretty simple stuff, but you can't forget how you take derivatives and antiderivatives from Calc 1, right? What else you want? You want other fun stuff with logs, natural logs, etc.? What else could we do? They have kind of a fun one there. You want to pick an odd? Let's pick an odd. Oh, that's implicit differentiation. How about 5 through 20? Let's pick one of those.
19.
19? Oh my gosh. I don't know if I can handle that.
17.
17.
Well, I can do 19. You want 17 instead?
Yes.
Yeah.
Taking the derivative? Hey, we taking the derivative of that? 2x.
I don't have my book open.
So Cameron, I guess you're up, right? So this is number, what, 17? And I want the derivative with respect to x of whatever was written there, right? What do you got? So you're just picking a number, x to the 5th, e to the minus, this is x to the 5th times e to the minus 3 natural log x. And I said 2x. So prove to me why that's right. I don't have the answer key open.
You said
I don't have any of my stuff. I said 2x. This is 2x. This is duh.
Gosh, Shay.
Cameron's gonna explain it to us, so don't worry.
All right.
Be a superhero. Heroin. Heroin. You can't say that word. You can't say heroin on a recorded event.
You have the you have
Cameron, drop the needle.
profanity check right.
And there was a reason I didn't show Shay's real dance because it was completely mildly inappropriate.
I want to know what was inappropriate about it.
All of their dances are inappropriate.
Thank you.
I thought it was better than the other
Yeah, that's what
dances.
it
It was. It was good. I loved it. I loved
Guys
it.
kept it tame. The girls got a little weird with their jumping around like little elves, playing their
The
hands
girls
around.
were weird, really. Okay.
Yeah.
Anyway, Cameron.
At least they had jeans on instead of little skirts.
I asked for a skirt.
What are you gonna do here? I'm not taking this derivative. You wanna use the product rule or what?
Yeah.
Okay. Do you?
Okay.
So what's product rule? So this, by the way, this is KV, Cameron Venner, for now,
Okay.
right?
So x to the 5th.
First times derivative of the second. Okay. So derivative of e to something
Yeah, so
is
it's e to the whatever that is.
minus 3 natural log x
Yeah,
times,
the derivative of that.
which is,
Ooh, got there.
what's the derivative of natural log?
1 over.
1 over. So this is,
-3 over x.
it is. Thank you. Okay. So first times derivative of the second plus, oh, we're gonna need some room. Second times derivative of the first, right? All right, you're still up. Let's get into this Cameron's way.
E to the -3 ln x times 5x to the 4th.
What? Would you say 5x to the 4th or 5 to the x 4th?
5x.
5x to the 4th. Thank you. All right, that's better. Perfect. So make that equal 2x. Do your magic.
Looks like no.
Like, how do you not see this stuff?
It's obviously-
What can I do here with this 5 and this x?
Make it
X to the 4th. Okay, good.
And then, I don't know, bring the -3 to the front.
Okay, you want to rewrite it? Minus 3 x to the 4th, e to the minus 3 ln x, and then plus 5 x to the 4th, e to the minus 3 ln x. Is that what you want to do? What can I pull out of these things? Wait a minute. This is the same thing,
Yeah.
right? So this is like minus 3z plus 5z, which would be what?
2x.
2z?
Well, in this case,
So you
2x.
But it's not an x, right? That's why I was using z's, because it's some function here. Anyway, this is 2 that thing, x to the 4th, e to the minus 3 ln x, right? Okay, so can you please make that 2x? You still up? This is your version, right? Like you chose this path, right? This is why all of your parents like me, because they know that I take you down the chosen path, not your chosen path.
That's what they said about Anakin Skywalker.
We're working on them. All right, anyway. It's never too late. Let's start today. Please make that 2x. Didn't I say the answer was 2? Oh, yeah, I even wrote it down without looking at any answers. I already knew it. But anyway, whatever.
Problem do is 2x.
Can somebody, let's just open it up to the crowd, or we could go to Hannah. What do you want? Hannah, they wanted you. Nobody wants to answer the question. How is that equal to 2 to the x? What is e to the minus 3 ln x? Let's just work on this one. And work on this one? E to the minus 3 ln x. What's that equal? Rewrite that simpler. I started class with this.
It's somehow got to equal x to negative 3, doesn't it?
How?
No, you rewrite it, then you take the derivative of it.
Oh,
I started class with this 3 times because I tried to record it twice on Blackboard Collaborate Ultra, and the writing utensil is not good.
it's x to the,
You should hear what I say when I'm not recorded.
it's x to the negative 3 because of the theorem, the definition.
By that theorem. Now, how can you prove that? It's x to the minus 3 power, right?
Because a to the x equals e to the x ln a.
Yeah, we started class saying a to the x power is e to the x ln a, right?
Yeah.
But wait a minute.
So x is the a.
Well, can we switch it?
Why can't we?
Maybe we didn't start with that, but how could I do that? What could I do with that minus 3? Could I put it on top? Can I put it on top as an exponent? So this becomes e to the natural log of x to the minus 3 power, right? And then what happens with what happens now? E to the natural log of something. These undo each other, don't they? And you're left with x to the minus 3. So just pop that up there, and so what does that equal? X to the minus 3. So this is equivalent to 2x to the 4th times x to the minus 3 power, same base, add exponents, and it's 2 to the x, or 2x. What I have in my head, 2x. Did I do all that stuff in my head? Did I do the power rule in my head?
Yeah.
Who's up, Drew? No.
You look at the back of the book.
I'll be a fool. Really? We got game film to prove that didn't happen.
No.
You can just see it like Rain Man. Here we go. How'd I do it? Somebody open up to the audience.
354.
Because I'm good at this game, right? Tom Brady retired. Hey, I'm still going, baby.
Yeah, but you're teaching math, you're not playing.
You're like Alvin
You get-
Kamara.
You ain't gonna put me on the calculus bench. I'll tell you that. I don't care how old I am. Don't be pulling your age discrimination on me, baby.
Did you see how Kamara got arrested at the Pro Bowl?
Is the hardest.
I haven't watched it yet. Just let me watch it and talk to me Wednesday.
I don't think you.
Let's finish this. What did I do? Hey, I got an idea. What's that equal?
Oh,
Uh,
x to the negative 3.
I'm going to rewrite this sucker. Instead of using a product rule, I can rewrite this as e to the ln x to the minus 3 power. That cancels. That's x to the minus 3rd. So this is equivalent to the derivative with respect to x of x to the 5th times x to the minus 3, which same base, what do we do? Add exponents is the derivative with respect to x of x squared, which is 2x. That's how I roll, baby. Woo! What?
I did that 5 minutes ago.
Oh, wait.
All real numbers.
Get that in your nose. All real numbers, baby. That works for all real numbers. TR. Hey, that's me. Cool cut. Woo! What else you want? Pick another one. Let's see. Let's do an antiderivative that you're gonna make hard and when it's really easy. So we got, I don't care. 25 through 32. Pick an odd. 25 through 31. 27. Ooh, great. If I can read it, it's the integral of 1 plus e to the 2x over e to the x plus dx, not plus, times, with respect to x. I believe it's this. Oh my. Now, we're just going live off the cuff, so we have no idea if I can actually do this stuff, but I do.
You're just procrastinating.
Who's up?
You're figuring out
Who's
the
up?
answer.
No, I'm not figuring it out.
Three's up.
You're stalling.
What can you do, man?
I don't know.
Balls in your
We gotta do something. That didn't really work for me.
You can't act like it's okay. I don't know.
Okay, lots then.
Act like it's okay. Yeah, act like it's okay. Act like you have hope. Help me, Obi-Wan. You're my only hope. All right, well, how about we use laws of fractions? Could we start with that?
I think
Bring a
the
Star
real
Wars
question is
reference in.
a little-
Not quite as, I don't have the side buns on my. Help me, Obi-Wan. Like,
Can't say I ever
I
watched
can't really
Star
hear you
Wars.
Does
with
that
my
make
headphones.
sense? R2-D2?
What?
Can't say I ever saw Star Wars.
Wow.
You were missing life, dude.
They're very good.
So Haas, you're up. I'm skipping Eli, because you have, right?
What? Yeah.
Yeah, you seem fine.
Yeah, yeah, Haas, you're up. Law of fractions, split it up. I said use principal law of fractions.
So law of fractions.
What's A over C plus B over C equal?
A minus B over C.
What?
A plus B over C.
It's A plus B all over C. Same, you got a common denominator, add the numerator, keep the denominator, undo it, go the other way, go this way. I got a sum of a binomial up here,
One
divided,
over e to the x plus e to the 2x over e.
right? With respect to X. Why did I do that? What can I do now? Integral of the sum is the, Garrett,
Some of the integral.
sum of the integral. So it's the integral of 1 over e to the x with respect to x plus the integral. Can you go ahead and simplify that a little bit for me? What's e to the 2x divided by e to the x?
Something,
Yeah,
e to the x.
you sure?
Sure.
Same base, subtract exponents. 2x minus x is x, right? So, or on top, you could rewrite that as e to the x quantity squared, right? Using the amen rule that we just talked about. All right, but anyway, we got this. Can I handle that? What's this one? Let's do this one in blue. What's that?
E to the x plus c.
This is e to the x. We're gonna put the plus c at the end instead of doing a plus c2 here, because I got to do this one. So this is now my challenge right here.
Easy.
How do I do that one? Shay, you're up.
We're
I'm gonna rewrite it.
gonna let.
By the way, that's a plus. Since that's a plus in here, that's a plus. I'll just rewrite it.
Rewrite it.
Couldn't prove that.
I don't know.
I don't want the e to the x in the denominator. Get it out of there.
Multiply it then.
Put it in the numerator.
I don't know.
How do I get that in the numerator?
Copy dot flip. I don't know. Let me go back to my notes.
E to what power?
X.
No, that's in the denominator. I want that in the numerator. I want to move it upstairs. What do I do with the exponent? Opposite sign. E to the minus x. Can you take the antiderivative of e to the minus x power? What is it? Well, let's go over here. The antiderivative of e to the minus x power with respect to x. What don't you like? You don't like that minus x, do you? Because I know the antiderivative of e to the x. So what am I going to do with that? Cameron, back to you now. How'd you have all that hard stuff and then now you got this easy? So I'm going to let what? I want the antiderivative of e to the minus. I don't just want to say that the antiderivative of e to the minus x dx is minus e to the x. Minus e to the minus x.
So let u equal negative x.
Let u equal minus x. What's du equal?
-1 dx.
Okay. Yep, minus dx. I don't care if you got the -1 there, but I just want dx, right?
So dx.
So I can divide both sides by -1, but du divided by -1 is the same as du times -1. So you can multiply both sides by -1 in this case. Thanks for joining, Shay. It's about time. Anyway, so I got minus du. So this is equivalent to minus the antiderivative of e to the u du. So that's a minus sign out front. Don't forget that. Antiderivative of e to the u is what? So this is the minus sign that was out front. E to the u, and then plus a constant, right? I'll just call it plus C1. So if you want plus C2 down here, I don't care. But anyway, we'll get the constant at the end, but now I'm going to back substitute, right? So this is minus e to the minus x plus C1, right? So that's the red one. So this is minus e to the minus x plus C1 for that one, plus this one. And then, of course, the constant, I told you, I don't really care if you write those down as you go, as long as you write it at the end as a plus C. But the final answer to this then is what? Minus e to the minus x plus e to the x plus c. If you don't believe me, take the derivative back and make sure you get what's in here.
What happens if it e to 2x?
Where'd it go?
You cancel with the e to the x.
I did law of fractions. I use this little ditty right here. The other way. So basically you need to learn some manipulation tricks, right? So we need to make this, we need to rewrite these in a way that makes our life better, right?
Right.
So if you're stubbing your toe, now that the only way to really see this stuff is through practice and execution, right? It's like you got to see it, and then you got to be able to come up with that stuff on the fly. So you really need to do more odd exercises than you've been doing, which is not nearly enough. You've been maybe doing one that's like the even. You can't do that anymore and be successful. Those days are over. Not only are you college level students, you're higher level college level students because you're in Calc 2 now. Time, energy, effort, execution. Let's go. When you have questions, you reach out to me. Say, Tim, I'm really stumped. The quotient rule is really awkward here, and I'd be like, I know the answer is 2x. Right? So like if you see it right, do it right, show it right, and see the path that makes it easy based on what you already know, life's good. Life's good, baby. Life's good. It's great. See ya.